So to continue from yesterday, at the end of class yesterday, we generated Java documentation for the class that we had written. I think that's kind of cool. And we used /** to start our Java comments. We used @param and @return to document the parameters and return values specifically. And we focused on documenting the methods. Today, we're going to take the next step in what's called test-driven development. We're going to write our first unit test. And so the theory behind unit testing is that if you test a class in isolation before so in terms of unit testing here, the idea is that we test one single class all by itself before we integrate that class into a bigger system. In this example we're doing here of writing this mileage tracker class, we want a unit test for the mileage tracker class before we put this mileage tracker code in the rest of our dashboard system for the car or in the rest of our mobile app or whatever the other software system is that it's being integrated with. The reason for this is it dramatically improves productivity. So if we can test a single class, and if we can build confidence that it works as intended, then as we're testing that single class, if we run into an issue, well, guess what? We know it's in that class, and that makes it a lot easier to debug. When we do integrate that class into the wider system, we know that as we're debugging the broader system, we have a high degree of confidence in the quality of each individual component, and we can focus our debugging effort on the interactions between those components, which are often more sophisticated bugs and trickier and harder to debug. But it's a lot easier to do so when you know the class itself is solid. The tool we're going to use for our unit testing and the tool that's used in Java is called JUnit, and it makes it easy to write unit tests. So switching back to BlueJ here, we're going to do some useful new features in BlueJ. So first step is we need to turn on some preferences, which, well, here, this is where I need some help. I'm not sure what your thing is going to look like. Do you all see this testing section in your BlueJ window? Give me a thumbs up or a yes check or something. Okay, good. All right. I wasn't sure if like this would show up automatically for you or not. It probably does because we already have the teamwork stuff here for our code. Cool. So this is good. We're going to use these buttons in a moment to test our code. But here's the first cool thing. The first cool thing is that BlueJ has some integration with JUnit to make this test relatively easy. So what we're going to do as the first step is we're going to right-click on the mileage tracker class. So I'm right-clicking on the little box here in the BlueJ window, and I'm going to choose the last option in the menu, which says Create Test Class. And when I choose that, there will be this green rectangle that pops up behind that we can't completely read the full name of, but it says mileage tracker test. It's got this little annotation on the top that says unit test. It's in a different color. This is the test class that was just generated associated with a mileage tracker class that we wrote yesterday. So we're going to open up the green test class and we're going to write some tests. And this might seem strange, like, wait a minute, Mr. Schmidt, we never actually wrote any implementation for our methods yesterday. All of our methods are empty or they just return 0 or null. Like, I don't think the tests are going to pass. And you are absolutely correct. When we do test-driven development, we write empty method bodies for our public interface. Then we write the tests, and then we run the tests to make sure they all fail. Because if our tests pass and we haven't implemented our class yet, well, then our tests aren't very good. So we want to make sure that our tests fail. Then we'll go back and step by step, we will implement these methods. And as a result, we will see that our tests start passing. And that's the process of test-driven development. So I'm going to open up the mileage tracker test. And there's a lot of code that's already generated here for us by the JUnit template that's integrated with BlueJ. Everything that's in here, we're going to leave alone. If we're doing more sophisticated testing, we might add some code to it and whatnot, but we're not going to worry about that for anything we're doing here. So instead, we're going to write a few test methods today. And the good thing about writing these test methods is they should seem familiar because they're going to be focused on creating new objects and calling methods on those objects and capturing the return values of some of those methods. Writing tests is a lot like we did in the last unit, except instead of dealing with turtles, today we're going to be dealing with mileage tracker objects. So we're going to leave all the code that was generated, and at the end of this file, but before the closing curly bracket for the class, we're going to start writing test methods, right? And so here's the first test method that we're going to write. You may notice that there's more of these @ symbols here. These are these little annotations that show up in Java sometimes. They're usually interpreted by different tools. They don't affect compilation, but they could affect the compiler itself in terms of warnings and things. So every test method needs to start with an @T test. Okay? That specifies to JUnit that, hey, this method is a test method, and when I ask you to test my class, this is a method that I want to run. All test methods must be public. All test methods must have a return type of void. And by convention, we name our test methods with the prefix test, and then the rest of the name is the name of the method that we want to test. So looking back at our mileage tracker code, one of the first method that we wrote yesterday, or that we at least declared the method header for, was increment miles driven. So let's write the test method corresponding to that. We're going to write a test method for most of the methods in here. In general, you write a test method for every method in your class. I don't know if we're going to quite take time today to do that. We'll see how we do. But we're certainly going to say test increment miles driven. And then we'll have our curly brackets for our method body. All tests kind of start the same way. If we want to test the mileage tracker class, we need to create a new mileage tracker object. So let's do that. We're going to declare a variable of type mileage tracker. I'm going to call it test tracker. It's the name of my variable. And I'm going to assign to it a reference to a new mileage tracker. And then the method we want to explicitly test is the increment miles driven method. Well, let's actually call it and make sure it works. So on the test tracker variable that refers to the mileage tracker object we just created, I'm going to call the increment miles driven method, and I'm going to pass it a value of 10. The car is reporting to the mileage tracker object, hey, we just drove 10 additional miles. In order to check if this method works, we're going to have to call the corresponding accessor method. So looking back at the mileage tracker class, there's also this get miles driven method. So this is the method we need to call to see if it actually returns the value we expect. So in a local variable of type double called amount, I'm going to store the value returned by calling the get miles driven method on the test tracker, on the object referred to by the test tracker variable. So test tracker.get miles driven. Now what we could do is we could run this, we could print out this value and we could run this code and then we could visually inspect, hey, is the amount equal to 10? And if it is, we know our test is in a good place. And if it's not, we know we have a problem. And that would work, but it doesn't scale well. And so a big part of unit testing is to make the unit testing automated. Computers are really good at comparing numbers. We want the computer program to check if the test passes. We just want a summary if the test passes. Because if we're just testing a few methods and we're just doing it in class, yeah, we could visually look at it and figure it out. But imagine as this scales up, imagine as we have dozens of classes or hundreds of classes or thousands of classes. Imagine that every time you do a commit and you push code up to GitHub, you want your unit test to run automatically on some server somewhere and send you an email or a notification if a test fails and it was your fault that you broke something. Where I used to work, we would test the entire software stack every night. And to run all those automated unit tests would take hours. Certainly not something you'd want to do by hand and visual inspection. You want the whole thing automated. So we're going to use a special function. And it's one of these special functions that we don't have to call on an object. We can just use, or a special method that we don't have to call on an object. We can just use the method name. And it's called assert equals, ASSERT equals. I did not share my screen the proper way. Let me do that right now. I apologize. Try to make this a little clearer for you all. There we go. Much better, I hope. Keep the chat open. All right. So assert equals, ASSERT equals, it takes several parameters. The first parameter is the expected value. What do we expect the value of this amount variable to be? Well, we made a brand new mileage tracker. We drove 10 miles. We'd expect that when we call get miles driven, the value would be 10. The second argument that we're passing here is, well, what is the actual value returned by the object? Well, we stored that in the variable amount. So the second parameter is amount. If I just leave it like this, we have a little bit of an issue. And the issue is that doubles, floating point values, there are, and we'll study this more in the next chapter, but there are quite literally an infinite number of real numbers, right? Think back to math class, infinite number of real numbers. A computer, when it stores a double, has a finite amount of space to store that number. So a computer cannot represent an infinite number of real numbers. A computer can only represent a certain number of real numbers, a huge number, but not all of them. So as a result, there can be some rounding errors that show up for different real numbers and show up when we do calculations with real numbers. So therefore, whenever we compare a double value, we need to basically tell this assert equals method how close is close enough. If we're off by an entire mile, is that okay? The answer is probably no. But if we're off by like a millionth of a mile, do we care? Definitely not. Okay. So the third argument that we specify here, is what's called the epsilon value. That might be a term familiar from math class, but it's basically is how close is close enough to be considered equal. And we're going to specify that is 1/millionth, a 1/1,000,000th, so 1e to the negative 6. So we can use scientific notation in Java. This is how we do it. 1e to the negative 6 is the equivalent of 1 times 10 to the negative 6 power. So I'll put that in a comment here just for context. So if the value stored in the variable amount is within 1/1,000,000th of 10.0, we're going to call it equal. This definitely is worthy of a comment, so let's make a little comment block here above assert equals. And we're going to say the assert equals method verifies that the expected value is equal to the misspelling, equal to the actual, we can think of the actual as the returned value. If not, the test fails. This is important because of how the errors will be printed. We should specify the expected value first and the actual value second. Otherwise, when tests fail and we get the nice message from JUnit, we'll be confused. So expected first, actual second. For values of type double, and this whole thing only applies to doubles, just we're dealing with doubles at a minute. So only for doubles, specify a third value, which is the epsilon. And again, by epsilon, what we mean by that here, same concept as a math class. You may or may not have studied that yet in math class, but how close is close enough to be equal? Cool. So that's our assert equals method. So now we have a little test method here. We made a new mileage tracker object. We called the increment miles driven method, which is the method we want to test. We called the get miles driven method to see if it's the expected value. We have this assert equals method, which is kind of unique because we're not calling it on any object. That's a special feature of how JUnit has that set up. And our test will either, our test here will either pass or fail based on if these are equal. The word assert shows up in a lot of different programming languages. And what it means, assert means the same thing it means in English. It means make sure the following thing is true. So assert means make sure these two numbers are equal. And if they're not, let us know. When writing a good test, you want to try to think through what potential bugs might be in the code. You might want to think through testing different like boundary cases and things. So we can make this test a little bit better because maybe it works fine the first time you call increment miles driven, but maybe when that method is called subsequent times, there is a bug. So let's actually test that, and we can have as much code in this test method as we want, and we can call assert equals as many times as we want. So let's call increment miles driven again and pass in 5 more miles. And let's call get miles driven again. And I'm going to reuse the variable amount. I don't need to specify that it's a double because I already declared amount up here. We're still in scope. Java knows that amount's a double. So I can just use it again and call get miles driven. And let's do another assert equals. Now we would expect a value of 15, and we'll check it against amount, and we'll use the same epsilon value. Cool. So I'm going to hit the compile button here, make sure our test compiles, which it does. And this is what's so rewarding, at least to me, about test-driven development. We wrote one test method, but now we get to like actually run our code and see what happens, right? And we'll come back and write another test method in a second. But if we switch back to the main BlueJ project window here, we can actually click on the run tests button right here to run all the tests in this entire BlueJ project. If you want to run a subset of the tests, you can actually click on just the test, right click on the test class, and you can choose test all, or you can choose a specific method to test. I'm going to choose test all because I like the user interface for that. So I'm going to choose test all, and the test result window pops up, and the test increment miles driven fails. Red X, 1 failure. Here's the assertion. This is kind of cool. Java.lang.assertion error. Expected 10.0, but was 0.0. This test failing is a success. This is exactly how test-driven development is supposed to work. Of course our class fails because we haven't implemented it yet. This is what we want to see. Okay. Let's write a couple more tests, and then we'll try to get them passing. So we're going to skip over fuel consumed because it's pretty much just like this one. And I'll share some code with you later for completeness if you want it. But let's test get mileage. So one of the methods that was provided for you, but we haven't implemented yet, is the get mileage method. This is the one that actually calculates like miles per gallon. So that would be a pretty useful test. So let's add another test method here to our mileage tracker test class. So we have to start with that test. Good to get a little more practice here. Public, always void, prefixed with test. The method we're doing is get mileage. Excellent. Curly brackets for the method body. We're going to start much like we started the previous test method. We're going to make a new mileage tracker object and assign it to a variable test tracker. So mileage tracker, that's the type of our variable, test tracker. I can use the same variable name again here because I'm now in a new method, meaning I need to specify what its type is, equals new mileage tracker. Cool. And in order to test the get mileage method, we're going to need to drive some or report that the car has driven some. So test tracker dot increment miles driven. Let's say we drove, the car reports to the software that we've driven 100 additional miles. And while doing that, we're going to increment the fuel consumed. In driving those 100 miles consumed, we consumed 4 gallons of gas. Excellent. The method that we want to test is the get mileage method. So we'll create a local variable of type double. I'm going to call it mileage, and I'm going to assign it the value returned by calling the get mileage method on the object referenced by the test tracker variable. And then we're going to do the same type of assert equals as we did before. So assert equals, we would expect, so if you think of like your mileage, miles per gallon or miles for every gallon, if I drove 100 miles and it consumed 4 gallons of gas, I'm getting 25 miles for every gallon of gas. So we'd expect a value of 25 here. And again, we'll specify an epsilon value of 1e to the negative 6, which is plenty small. And that's it. Now we have a second test method. And this test method will test the get mileage method. Indirectly, it also is testing the increment miles driven method and the increment fuel consumed method, but these methods should have their own individual tests as well to make it easier to debug, like we wrote for this one. We only skipped over increment fuel consumed just because we're limited on time. Let's see. I think we have time to do one more method, and we're going to come back to this method tomorrow, but it's good to start it today. Actually, we'll wait. I want to make sure we get to a good stopping part today. We're going to write a method to test the set VIN as well, but we'll do that tomorrow. So we have this method set VIN where we pass in a reference to a string and it stores the vehicle identification number. But we'll do that tomorrow. We're just going to focus on these two methods for today. So if I switch back to my main BlueJ project window and compile everything, I can now right-click on the mileage tracker test class and say test all. And now I can see that I have 2 failures. Things are getting worse. How do you go about testing classes independently if a class contains an attribute of another class? So you kind of do it, I would say you do it like incrementally. So for example, when we write our test set VIN method, we will certainly be dependent upon the string class because the string class is part of that set VIN and get VIN method. And so basically, from the incremental perspective, if we're using the string class, we assume that that string class has already been tested and works as advertised. And we kind of go forward with that assumption as we start testing our mileage tracker class. Part of this is related to how you decide when code should be available to others to use. And the idea is that you wouldn't have other people using code for a given class until it passes all of its tests, because you want them to be able to count on the quality of the code that you're providing. So that's how we deal with those types of interdependent issues. There are some other interdependencies between classes that we might be writing that we can't completely address in the context of like a unit test. And that's where system tests come in. System tests explicitly focus on the integration between classes. Let's try to make some of these tests pass. I think that would be a great place to start. So in order to do this, we need to switch back to our mileage tracker class, and we need to implement some of these methods. But before we can really do that, we've only really addressed so far one of the two key aspects of what makes a class a class. We've been focused on the methods, the abstraction that the class provides, and that's super useful. But we haven't done anything yet for the state of the class. We haven't done anything related to encapsulation. What is the data that the object holds on to? What is that? What is the state? So methods describe like verbs. They describe actions that you can perform with an object. You know, the turtle has turn left, turn right, forward. But we're going to add our instance variables, and instance variables focus on the attributes of the class, the state of the object. In the case of mileage tracker, it's going to be stuff like, well, how many miles have been driven? What is the vehicle identification number? In the case of the turtle, it's like, what is the X position? What is the Y position? What is the mileage? So what we're going to do next here is we are going to declare instance variables. And they store the object's properties. And for each instance variable, we're going to specify a visibility, a type, and a name. So let's see an example of what that looks like. By convention, our instance variables go at the top of our class definition. So I'm going to scroll all the way up here to the start of our class definition. And after the opening curly bracket, I'm going to add some space for us to have our instance variables. Okay. And I'm going to write one instance variable first. And I'm going to start with visibility, private. I'm going to start with the type of the instance variable, double. And then the name, which is going to be miles driven. Personally, and maybe it's the science teacher in me, I like to be clear about the units. So often I always it's pretty clear because it's called miles, but I'm going to say in units of miles just to be extra clear, like how we're measuring things. Units are super important. You confuse units in code, and you end up sending spaceships crashing into Mars. So let's be careful with our units. All right, number 2. So step 1 was to define our methods. Step 2 is to do the instance variables. I'm numbering these again because it can be confusing because we're going out of order, right, in terms of where it is in the class. So step 2 is to define the instance variables. And this stores, an instance variable store the object's attributes. And there's 3 parts to that. We specify the visibility, private. In general, instance variables are always going to be private. That's the very nature of encapsulation. Okay. Public means, since we didn't declare this earlier, or I guess I should have done this down below. Public means it's accessible by any code in any class. If our instance variables were accessible by any code in any class, that would violate encapsulation. That would make it hard to add new features or fix bugs in our class. Private means it's only accessible by methods in this class. And that's exactly what we want. This instance variable miles driven, we can refer to it anywhere within the mileage tracker class, but nowhere outside of the class. And that's what encapsulation is all about. Next, we want to specify the type of the variable. In this case, it's a double, storing the number of miles because we might have fractional miles. And then finally, we specify the name of the instance variable, which in this case is called miles driven. Now, here's an important thing. We haven't done anything with instance variables before. This is a big new concept for today. And so what I want to be clear about is this instance variable here has certain key differences from local variables like amount declared here inside of this method. So it's worth a couple of comments here to explain that difference. So instance variables differ from local variables in the following ways. So this is helpful to kind of compare and contrast the two. So instance variables are scoped to the class. What I mean by the word scope, this is a generic programming language term. Scoped means where is the variable accessible? So when I say scope to the class, I mean it's accessible in all methods of the class. So anywhere in this class, I can access the instance variable. The other part of that is like the lifetime, meaning how long does this instance variable exist? The lifetime of the instance variable is the same. Whoa, I totally jumped to a different thing. Sorry. Is the same as the object. So a local variable, switching back to our test code here, a local variable is scoped to whatever code block it's in. In this case, it's just this much code right here. The lifetime of this local variable, meaning like when does it exist and its value actually stored, is limited to, again, the code block. It doesn't exist beyond this chunk of code executing. Whereas this instance variable miles driven can be accessed as scope to the entire class, and its value will continue to exist for the entire lifetime of the object. So that's a key difference. That's a huge difference. And that's really the whole point of an instance variable. This is how we store the state of the object. Instance variables are exactly like attributes in Python objects. Absolutely. Here's another difference. Instance variables are automatically initialized to a default value. That default value is like 0 for an int or a double. It's false for a Boolean. For any instance variable that references an object, it's initialized to null, having a null reference, meaning there is no object it refers to. Best practice, and the reasons for this are a bit beyond the scope of this course, but we'll still learn best practice. Best practice is not to immediately initialize instance variables. So you'll notice here, I don't say miles driven equals something. I just have the semicolon. We're going to learn tomorrow where we initialize our instance variables, but best practice says don't do it here. So these are the key differences between instance variables and local variables. Let's add 2 more instance variables. Let's add another one of type double called fuel consumed, keeping track of how much fuel has been consumed that's been reported to this mileage tracker. That's going to be in units of gallons. And finally, let's keep track of the vehicle identification number, VIN, which is of type string. And that's our vehicle identification. There we go. So that's kind of our big new concept for today. This is a good place to pause, which is good because we're about out of time for class today. So tomorrow we can learn how we initialize our instance variables, and then we can go and start to implement some of these methods and get these tests to start to pass. So we'll move on to our next phase of test-driven development. Hope you all have a fantastic day, and we will keep going with this tomorrow. Thank you, everyone.